Hi there. So what we want to talk about in this video is what are called percent problems that involve using algebra. Okay. Now, to understand what a percent is looking at that actual word. It comes from a Latin phrase. Per means out of, and then cent means 100. So this means out of 100. Okay. And if you remember, this little symbol means percent. Okay. And so whenever we write that symbol after a number, we're talking about out of 100. All right. And so if I write something like 37%, okay, well, what does that mean? That means 37 out of 100. All right. And so since we're talking about 37 out of 100, we could write that as a fraction as 37 over 100. And then if I divided those two, that comes out to be 0.37. So this is mostly review, but if you remember, there's three basic ways to express numbers now, all right? And this is pervasive through all math, okay? We can express answers or numbers as fractions, or we can express them as decimals, okay? And another equivalent way to express them is as percents, all right? And hopefully you've seen this before, but there's ways to go from one form to another. If I want to go from if I'm given a fraction, I want to get its decimal form, I just divide on my calculator, okay, or by hand, all right? And then once I have the decimal, let's look at that just in case we got to look at it backwards. But if I started with this decimal, how do I get it in percent form? Notice I have the same numbers, but all I did is move that decimal point 2 places to the right, all right? And so to go from decimal to percent, I move the decimal point 2 places right, and then I include that percent sign, all right, like that. Now, we can also go the other way, and you just do everything in reverse. So if you start with a percent, then you can always get its decimal form by moving the decimal 2 places left, and you'd want to drop the percent sign, okay, like that, and so that gives you the decimal form, like that. And then if you need to get it in its fraction form, then you write it using place value. I'll explain that real quick, but yeah, we want to do that with place value. Okay, and so this is mostly review, so I'm kind of being quick here. But sorry about all that. Oh my goodness, I'm just going to have to move this out of the way. Let me just leave that last line there. Okay, so just to illustrate this, what I just said here, say I started with, I'm going to do kind of a complicated one. Say I started with 8.3%. Okay, and so if I wanted to get its decimal form, like that, then I would take the decimal point and move it 2 places to the left. And so I'd move it 2 places to the left. If there's a blank space in front of one of your places, we're going to want to put a 0. And so the decimal point version is 0.083, like that. Remember, we dropped the percentage sign. Okay, now if I want to get its fractional form, like that, the key thing is you got to think place value. So you got to remember what these numbers mean. This is the tenths place. This is the hundredths place. This is the thousandths place. So I have 83 over the thousandths. So 83 over 1,000, like that. And if you could reduce it, you would. This one doesn't reduce. All right. So that's just quick review. Now what we want to do is look at some percentage problems that involve some more thinking and where algebra comes in to help us. So there's just kind of a basic technique that we use to solve problems that involve percentages. And make sure you realize percentages we see all the time out there in the real world, so we need to get a way to deal with them. And it comes from this basic idea, like we said in the last slide. Fractions can be written as percents, okay? So think about what the basic idea of a fraction is it's the idea of expressing a part to a whole, like that, okay? Now, since they can be written as, that means that they're equal to percents, just in a different form. And then what does percent mean? That's out of 100. Okay? And so over on the right, we'll have the percentage over 100. Okay? And now what that allows us to do is, in most problems we're giving so there's three things here. This is always 100. So we have four parts in the fractions, but this is always 100. So there's three things here. So what will happen in most percentage problems is we'll be given two of these. We might be given the part and the percentage, and we want to find the whole. So we'll be able to fill in two of these slots with actual numbers and then solve for the unknown. All right? And notice that this is a proportion right here. And so the last few videos we've been solving a lot of proportions. And so this thing right here is a proportion, and so we'll be able to solve it by equating the cross products. The only real tricky part in this whole process is isolating from the wording what is the part and what is the whole. So let's look at this problem right here. Okay, so we have 80 is 45% of what number? Okay, and we can solve these all the same way. We can just think about the part over the whole equal to the percent out of 100, like that. Okay, now if you notice, the percent is given to us, all right, and so we can write 45 over 100 over here on the right. All right, the question is, which part in here is the part and which is the whole? Now notice we have these two things given to us. We have this 80. Okay, now the second part isn't given to us, but we have this what number, okay? And so remember, that's going to end up being our variable. We can call it x if we want to, okay? And so now which one of those is the part and which one of those is the whole? Well, we have this 80, but it's a part of some number, okay? Do you see that? 80 is something of another number, so 80 is a part of this number. And so that part is the 80, and the whole is what we're trying to find, the x. Okay, and so notice now we have a proportion, and so here's our two cross products that we equate. Okay, and so I multiply 80 times 100, that's 8,000. Okay, and then we get x times 45, or 45x. All right, and now notice this is a simple equation to solve. We just divide by 45, and then since percentages are kind of a way of expressing a decimal form, we can answer this in decimal form. So we can just type in 8,000 divided by 45 on our calculator. All right, and now notice on your calculator there, whenever you plug that in, pause right now and plug that in so you see that. See what it gives you. It doesn't give you a nice even number. I don't know what's going on with the screen, sorry. All right, so whenever you go and plug in for x on your calculator, it's going to give you 177.777. It gives you a bunch of sevens, and then that last digit is 8. Okay, now you got to think about what's going on here. Remember, decimals often repeat themselves, and so notice we have all these sevens. Why is your calculator showing 8 at the end? It's because your calculator can only display so many digits. It doesn't have an idea of infinite decimals. So it's rounding that last one. Okay, so what's really going on is I have these sevens repeating. All right, and so if we wanted to keep things entirely correct, we could say x is 177.7. And if we want to indicate that that 7 repeats forever, remember from your arithmetic classes, you can put a bar over that 7. And so that is the answer to that problem. You could also answer this in fractional form. You could go through and reduce down that 8,000 over 145. That's going to end up being 177 and 7/9 if you would prefer to write it that way. Okay, so here's 3 problems that we'll do, example problems. So you guys, as always, you probably want to pause and see if you could figure them out on your own, just based on that brief explanation. But otherwise, I'm going to carry on. And so the idea on all of these, since we have a percentage problem, we have the part over the whole is equal to the percent out of 100. And it's just a matter of isolating what each part is. And so, first of all, notice no percentages are given. The problem asks for the percent. So this is going to be our variable right here. All right. And so we're going to have equals x out of 100. All right. And then we have 15 of 80. So that 15 is the part and the 80 is the whole. Now, in terms of just basic math problems, they usually will have this form. And so whenever I first learned it, I had a teacher that said the is over the of equals the percent out of 100. That'll help you with the basic math problems, but usually with the wording in actual application or word problems, they're not worded exactly that way. So I would advise thinking in terms of the part over the whole equals the percent out of 100. But anyway, once you get to that point, now we have a proportion. So notice that here's my two cross products. And so I multiply 15 times 100. That's 1,500, sorry. 1,500 is equal to 80 times x, so 80x. And so now to get x, I divide by 80, sorry. And so I have 1,500 divided by 80. And if I plug that in, I get 18.75. Now be careful of this answer. Okay, I'm going to come up here since I ran out of room. So x equals 18.75. But you got to ask yourself, what did this problem ask for? It's asking for the percent. So that x is actually a percentage. And so x is equal to 18.75%. Be very careful about that. Make sure whenever something is a percentage to include that percent sign. All right. Now, for problem 2, we have what is 84% of 200. So we have the idea of the part over the whole is equal to the percent out of 100. All right. And so the percentage is given to us. So we have 84 over 100. Okay. And then we're talking about something out of 200. So my whole is going to be 200. Like that. And so what we're trying to find is the part. Okay. So hopefully you realize again we have a proportion, and so I do my cross products. I get 100 times x, and then I have 200 times 84. That gives me 16,800. Don't let that throw you. Okay. So then you're going to isolate x by dividing by 100. All right. And then here we get x is equal to 168. Now, do I need to include the percent sign on this one? No, we were given the percentage. We were asking for the part, so this is actually just a quantity. All right. And so we get x is equal to 168. All right. This third one is very much like the first one, except it's a weird percent. And so 76 is what percent of 20? All right. And so hopefully you can see there, we're trying to find the percent. So we're going to have x out of 100. All right. Now, this one seems weird because you might think the whole is always the bigger number, but we're talking about 76 out of 220. So the whole is actually the 20 there, and the part is 76. Okay, like that. And so now if you equate your cross products, you're going to get 7,600 is equal to 20x. You divide by 20, and we get 380. And so x is equal to, let me write it the way the algebra would present it to us. So 380 is equal to x. And then again, remember that this problem asked for the percentage, so that 380 is actually the percent. And so x is equal to 380%. Okay, and just be aware, percentages can be very large, over 100%, like we're seeing. They can also be very small. You could have 0.1% or 0.6% or something like that. So don't let those throw you. Just double check your work and make sure you did everything correct. Okay, one type of percent problem that really throws people, but it also is very, very common in the media and in technical reports and so on. So unfortunately, our economy is not doing so well right now. So you might be hearing figures about employment, and so someone might say that unemployment has increased by, say, I'm just making this number up, but 28% last month. Okay, so we're talking about a increase, all right? And so that's the key thing is we're talking about a percentage, but it's just the percentage of how much it increased or decreased by, whatever we're talking about there. So whenever we start working with this, we still have the idea of the part over the whole equal to the percent over 100. But the key thing to understand here is that the part is the amount of increase or decrease, okay, depending on what's going on, okay, like that, all right, and then the whole is the where you started at, so it's the starting amount, okay, like that, all right, and so let's just look at an example of this, all right, and so say this is just a math example. We'll look at some practical examples in the next video, but say I have the number 8 is increased to 10. Okay, so think about this as a homework paper. I initially gave you an 8, but you pointed out that I had a grading error, so I increased your score to 10. All right, and say I want to know what's the percent increase. What's the percent increase, like that, all right? And so, first of all, in terms of basic notions up here, we're asking for the percent, okay? So the percent's going to be our variable here. So we would have x out of 100, okay? Now the key thing is we have this idea of the part over the whole, all right? But the key thing to remember is the part is the amount of, in this case, increase, since I increased something, and then the whole is the starting amount. Okay, so what did I start with? What did you start with? We started with an 8 equals x out of 100. The key thing is we don't use that 10 there. Okay, what we use is the amount that we increased by, and so we started at 8 and we increased to 10, so that would be 2. Okay. By the way, too, now that we have the proportion, we can just solve like we usually do, equate the cross product. If you do notice a fraction reduces, then it's easier for you to work with that one. Feel free to reduce it. So we could take another line and write that as a 1/4. I'm just going to go with it as it is. So, all right. And so we equate the cross product. So we do 2 times 100, which is 200, is equal to, and then the other cross product is 8 times x, which is 8x, all right? And then to isolate the variable, we would divide both sides by 8, and so we end up with 200 divided by 8, and 200 divided by 8 is 25, okay? Now be careful on this problem, though. What did the problem ask for? It asked for the percent increase, and so you were asked for a percent, and so we would say that that's a 25% increase. Okay, so here's 3 examples if you want to pause and try. Be aware 3 is a little bit tricky, so we'll talk about that. But you might want to pause and try at least the first 2, but maybe even 3 just to see how you do with it. Okay, so hopefully you did try them. But problem 1 we'll see is very much like the first example, just we get a much smaller a much smaller percentage. Okay, and so make sure you realize what the difference in this problem. We're doing percent increase, okay, and we're asking for the percent increase, so we're trying to get the percent, okay, and so the key thing is with percent increase or percent decrease, the part is how much you increased by. So notice that I started at 200 and I went to 205, so I only increased by 5, all right, and then the whole is what I started with, so I get 200. All right, and so now I have a proportion, and so I would equate the cross products, and so I get 500 is equal to 200x, and to isolate the variable, I would divide both sides by 200, like that, and so I end up with x is equal to 2.5. What you got to make sure and remember, though, here in this problem, we're asked for the percent increase, and so here I would say x is equal to 2.5%. Okay? One thing to point out too, if you're having trouble seeing how I get that 5, make sure you realize you started with 200, you went to 205, so how did I get that 5? That one's pretty obvious, but some of them are a little trickier. And so you just subtract the larger number minus the smaller number. Okay? All right. Let's see. So we have 400 is decreased to 100. There's nothing different here. This is just a decrease. And then we're asking for the percent decrease. And so so we're asking for the percent decrease. So that means we're finding the percent. So x will be the percent. Like that. And then remember, the part is how much I increased or decreased by. So I started at 400, I went to 100. That means I decreased by 300. Okay, 400 minus 100 is 300. And then divided by what I started with, which would be 400. Okay, and then I equate cross products again. So I get 30,000 is equal to 400x, and then I can divide by 400 to isolate my variable. Okay, and so those cancel, and so I have 300 divided by 4. You could do the whole thing too. I was just doing a little reduction there, and so I get, sorry about that, my hand keeps hitting the screen, and I get 75. So it'll be good practice once you think you have the answer on these problems to, because and once we get into applications, we'll also have to include units. So always ask yourself, what is x in this problem? Well, we were asked what is the percent decrease, so x is the percent, all right? And so our answer here is x is equal to 75%. Let me see. If you need to look at that, you might want to pause because I'm going to have to move some stuff. And let's see. I might have to move this to the next page. Let's see what happens if I try to. Yeah. Okay. I'm going to have to go to the next slide. So let's see here. So we need to. Y'all don't really need to see this, but okay, sorry to be bungling around here, but here we go. So this problem is very different, okay, because notice that we were given the percent in this problem, and this is the percentage of increase, okay? So we started with 50, and we increased to 20, and we want to know what the resulting number is, okay? So remember the idea, since we have a percentage problem, we can still follow this idea here. You might just want to, with these problems, you might want to write it out a little bit more carefully. So we're talking about a percentage increase here. Okay, so the part is the amount of increase in this problem because it tells us that we increase. Okay, and then the bottom is the starting amount. This leads to a very common type of application problem. So the amount of increase over the starting amount is equal to the percent out of 100. Okay, so the starting amount is 50, and we increased it by 20%. So we have 20 over 100. So that tells us the only thing left here is the amount of increase, and that's important. So we'll use it for x, but just remember the x is the amount of increase. The answer to this problem actually won't end up being x, and I'll point that out in a minute. Okay, and so now we have our proportion. And so here's our two cross products that we can equate. All right, and so our first cross product is 100 times x, so 100x, and then 50 times 20 is 1,000, right? Yeah, is 1,000. Okay, and so now I go to isolate x, and so I divide by 100. Like that. All right, and so I get x is equal to 10. Okay, but the key thing to realize this is x is the amount of increase. Why is this not the answer to the problem? Because the problem asks what is the resulting number. Okay, and so the idea here is we started with 50 and it's increased by 10. Okay, And so what does that result in? That results in 60, and so 60 is actually the answer to that problem. Okay, so following along that, let's do a similar problem with a decrease. Probably pause and see if you caught on to what went on in the last problem. But we started with this 800, but it was decreased by 35%, and we want to know what's the resulting number. Okay, and so in terms of the part, it would be the amount of, in this problem, decrease. Okay, out of the starting amount, that's the whole. All right, and then is equal to the percent. Well, let me just write the general form. Percent out of 100, right? So the amount of increase we don't know, but we do know the starting amount is 800. Okay, and then the percent, it's 35% out of 100, right? And so there's only one thing left, so we'll use that for x. All right, and now we have a proportion that we can solve for x. We do the first cross product, which is x times 100, or 100x. And then our second cross product is 800 times 35. 800 times 35 is 28,000. Okay, and so we get 28,000 with that. And then to isolate the variable, we divide by 100. Okay, and there you're going to get x is equal to 280. Now the key thing to remember though here, and I should have written it up above, what is x representing? It's the amount of decrease. And so x is the amount of decrease. Okay, and so what this 280 is, that's the decrease. That's not the result. Okay, like that. So this is the amount of decrease. Okay, and so we started with 800, but we decrease it by 280. Okay, and so we have 800 minus 280, and that's equal to 520. So our answer here is 520. Now these last two examples show up a lot, especially in retail and so on, all kinds of business kind of things, because we often increase, well, first of all, let's think about this problem with the decrease. When things go on sale, they're often put on sale by a certain percentage, like a 20% off sale, or this would be a 35% off sale. All right, and so we start with some amount that we usually sell it for, and then we're decreasing by a percentage, so we want to know what that sell price is. Same thing with increases. We often, especially retailers, will buy a product for a certain price, and then to ensure that they make a profit, it's called markup, but they'll mark up that the price that they bought it by a certain percent, and then that'll be the price that they sell it for. And these kind of things show up in a lot more than just retail, but that's the idea. And very often in employment, as you progress, your raises are often expressed as percentages. So you might get like a 5% raise, so you might be making this much per week, but then when you get that raise, you want to increase that by whatever percent, in that case 5%. So we'll look at those kind of problems in the next video though, but I hope that makes sense. One thing too, just to mention, I usually teach increase, decrease differently, and today in our Zoom session, someone pointed out that keeping with this format just helped them keep things lined up a lot more. So your feedback is always very appreciated, and I've decided to start doing it this way. I feel like it's a lot cleaner. Okay, all the best. Good luck.